I thought what I could do is perhaps spend some time on an aspect that we have really not looked at, and it's there in the title, right, in terms of IoT. Right? What really does IoT mean? So that is going to be what I'm going to be focusing on primarily, and a few more slides that we'll just pass along down the way. We are a product engineering services organization, right? We're based out of Bangalore, right? And we are focused around IoT product engineering, right? What that means is we don't build IoT products. We figured out that there is a lot of companies, there's a lot of industries that are building these products. We act as enablers, right? We help our customers accelerate go-to-market for their IoT products. That's what we do. And we focus around connected homes, industrial IoT, smart cities, intelligent buildings, right? That's our focus area. Now, this is a slide that I wanted to spend some time on. Right? What's really different about IoT? How many of you are aware that Durex has an IoT product? It's got a connected undergarment that can be controlled via an app. The IoT world is different, right? It's slightly different from the M2M world. M2M world devices have been talking to control systems and it's been a closed loop. The IoT world is about breaking those silos, right? What is also different is that there is a large number of devices that come, where the data is actually being gathered to where the data is actually being processed, right? Once the data is in a database, for the last 40, 50 years, we have been building IT systems. We know how to use them. We know how to query a database and build whatever kind of workflows we want, right? We heard a lot of very, very interesting discussions in the past sessions about all the e-commerce stuff, and all that is great, right? They have enabled a lot of people, but they're essentially IT systems. They're not IoT systems, right? What is different about IoT is that you have a small device somewhere which is extremely compute restricted, which is extremely communications restricted, right? Which can really not do much, trying to create an identity for itself in the whole world of the internet, right? It becomes addressable, right? It is not only addressable, it provides services to the rest of the internet. It starts to consume services from the rest of the internet. And that is what makes this interesting, right? We are no longer reaching to just the devices that are connected to my base network, the first degree of devices. We have to go beyond that. We are looking at devices that are connected via our cell phones. We're looking at devices that are connected via our set-top boxes. We're looking at devices that are connected via media gateways. Like, there's a whole bunch of gateways. And this is the peripheral network that is now starting to come up. And there are a lot of companies right from smart toothbrushes to smart light, right? It's a bunch of companies that are coming up. What is different is, in between the device that that produces the data, right? There are some intermediate, some field gateways. There are some regional level gateways. There are some enterprise gateways. All of them are different. They talk different protocols at all the layers of the OSI stack, right? You need systems to manage the compute, where exactly the computation is going to happen. Because if you're not managing the compute at the end node, what you're going to happen is you're going to be spending a lot of bandwidth trying to push all the data up to the cloud, right? And those devices are going to die because they're mostly battery operated, right? You have to manage the data that is coming in. You don't want the same data that is repeating itself over and over to come back to your network. It's meaningless data, right? I have to be able to optimize on that. I have to be able to manage the connectivity. Things will fall out of the network. That is the rule. You have to be able to manage the devices. What is the firmware on these devices? How do you do lifecycle management of these devices which are not even connected all the time? Those are the complexities that we as an organization deal with, right? And the way we go about it is what we call is an IoT accelerator toolkit, right? It's our unique approach towards building IoT solutions. And we create a whole bunch of modules, right, that we think can be, it's a plug and play module. You can use them in sync, and they would quickly quickly put together a solution using it. Or you can use some of our pieces, some of third-party pieces, right, and put something together really, really quickly. We cut down on the time it takes for your product to actually hit the market. Right? I will skip on this one and go to what exactly these components are, really. We have some hardware design capabilities which reside into, in terms of what we call T-boxes, and these are the kind of reference gateways that we make. Boxpod is our connectivity stack. And we have multiple flavors of this connectivity stacks because some devices are going to be on microcontrollers, some devices are going to be on low power processors, some devices are going to be running on full-fledged, today a smartwatch runs on a 1 gig processor, right? So there are different requirements, there are different protocol translations that you are doing over here. It could be a full HTTP to HTTP translation, it could be a CoAP to HTTP translation, it could be a CoAP to MQTT translation, there could be a whole bunch of translations that are going on, right? Also a lot of authorization, authentication that must be handled at this layer, right? So that is what the box, the connectivity layer, or what we call is our connectivity middlewares that happen. And then we have the entry to the cloud systems, right? And this is where we keep it really simple. We said all that it does is make sure that you get the right kind of channels. If a device is trying to communicate with you, make sure you give it the right kind of channel. Do not mix media and sensor data. If you try to do that, your systems are completely screwed up, right? Handle media, streaming data separately, have an IoT management function, right? Which is part of what we call is our IoT intelligence or device or data management services, right? And then we need to kind of manage the devices. We, out of the box, we come with our device management functionalities and a whole bunch of UIs and portals that allow you to integrate with your system really, really quickly. On the IoT intelligence part, which is the data services, we again look at there are essentially two kinds of data streams that essentially needs to be processed. One is your alarm streams, which is data that is coming in, is important, has to be processed now, right? You can build some, essentially what you're building is a whole bunch of counters. As the data flows in, it ticks the counters, moves on, right? You don't really care much about it, but what you care about is the value in those counters. The other part is when you're doing a lot of trend analysis. Not only is the data important, but it has to be stored, and you have to run algorithms which cannot be done in a one-pass mechanism to be able to get historical understanding about what the norms were, because you don't know them in the first place, and what is deviating from that norm. Right? So this is where a lot of large big data systems come into the picture, right? So essentially that is how these pieces come together. Any of these pieces are independent by themselves. So whenever you build a solution, somebody could use just the IoT intelligence part of it, right? So I'll keep it short. I will conclude with probably one example that we have been working on, right? Given the context of our smart cities that we have been talking about. So for one of our clients, right? And this client makes glasses, big window panes, right? They're also the world's largest electrochromatic glass company. So they can electronically tint their glasses, right? Using a window controller, right? Now you are talking about, all right, can I collect information about these huge glass panels? Now, can I start following the sun and make them tint when it is most bright? Then the starter came back to us and said, okay, can I now start integrating this with my HVAC system and turn down my cooling when my tint is high, right? Started gathering this data across multiple sites, right? We started building up historical models. Gradually, we are to that extent today where I can now look at the data and say that, hey, look here, your window controller took 3 times the time, the current draw was 3 times the normal, which means your cap is gone. Send somebody there to replace the cap, and this is the component that you need to replace. That is where we are today. That is what IoT enables you. And we, as an organization, provide you the capability to take your solutions to the market quicker, right? Oh, that's how the world looks us, boxes us in terms of where, as a platform company. In terms of solutions, we have looked at smart parking solutions. We have looked at smart lighting solutions. These are minimal viable products that can be taken to the market, right? We have looked at smart mobility, a fleet-based solution, but it's also a trip management solution. The idea here is we use analytics to figure out when, and you don't use any manual buttons. Use analytics to figure out when actually a trip is starting or ending, and how does that need to be managed, right? We have smart home solutions. These are extremely specific IPs that we build for OEMs, right? We look at employee health and safety frameworks, right? This is what we are working on with a consumer electronic company. We also have an ATM site monitoring solution. It's a great solution. Adoption, still not great yet, right? We have waste management solutions, and happy to talk about them in subsequent discussions, right? With that, I'll hand it over.